The Cummins case study deals with the world of integrated engine management systems. And at the time Cummins started this, they had about 25,000 employees. They were the world leader in big, heavy diesel engines, 50 horsepower and above. They had 350 controls and electronics engineers, and at the time about 100 software engineers. And the kinds of problems they were grappling with in this area of integrated engine management systems were, how do you achieve this optimum balance of the three major parameters of running a diesel engine? The power output of the engine, the fuel economy, and the emissions coming out the tailpipe. And any time you place an additional load on the engine, it tends to want to throw one or other of these parameters out of whack. And so the software has to deal with constantly adjusting these three major parameters. There are actually many more parameters, but these are the three principal things that must be kept in balance. And they were trying to move away from doing this in a point solution fashion to coming up with an integrated system based on what they call an ECM, an electronic control module, that would manage the information coming from all the different sensors around the engine to keep these three major parameters in balance. So if you are driving a truck and you are going up a hill, that places an additional load on the engine. If you are operating in extremes of heat or cold, that also places an additional strain on the engine, and it tends to want to throw one or other of these parameters out of balance. So the software has to react to these dynamically changing conditions to meet the goals of keeping these parameters in balance. You also have to, as a software developer, keep in mind that there are external stakeholders in your software, like the emissions control regulations. And in fact, Cummins typically has done a very good job of anticipating emissions controls, and they were one of the few organizations that didn't complain when the EPA introduced stricter fuel emission standards several years ago. They also place a heavy emphasis on the reliability of the software, because you can put an entire fleet of trucks out of action with a software bug, and that would be an extremely embarrassing occurrence. It's embarrassing enough when they're put out of action with a mechanical failure, but to have it come from software is just something that they really don't want to happen. The software itself is not exactly huge. It's about 130,000 source lines of code, at least at the time of the case study. I imagine it has grown a bit since then. And it runs on different kinds of sensors and platforms and ECMs. And Cummins was trying to move into this area of integrated engine management systems because they saw that as a greater or an increasing part of the value added in their engine products. So at the time, they were producing this software for Cummins as an internal customer, unlike some of our other customers where they, like Bosch, that are third-party suppliers of engine management systems and body electronic systems to companies like Daimler. This is, or at least was, an internal in-house effort, and the customers for these integrated engine management systems are the engine manufacturing operations within Cummins. So this all began in 1993 when Cummins had 6 customer projects underway and another 12 research projects, all working in this area of attempting to move into the world of integrated engine management systems. And they were operating in the classic stovepiped or siloed tradition of having different parts of the organization all essentially doing the same thing, trying to create an integrated engine management system, but each part of the organization had complete control over its development processes and its choice of implementation language. In fact, a couple of the research projects were trying to make Cummins' first foray into object technology. And senior management realized that they were having a serious problem with trying to come to grips with this whole integrated engine management approach. And they went outside the company and hired a guy named Ron Temple away from the Ford Motor Company because of his expertise in this area, and brought him in basically to bring some order to the chaos of all these multiple independently operating engine system projects. So he spent about a year reviewing all of the projects, talking to people across the organization, looking at the kinds of software issues they were having, and at the end of that year he decided he had seen enough, and he called a halt to all of the projects. So this is what I mean by having a product line champion at the right level in the organization who can make the hard decisions necessary for the long-term health of the organization. Temple realized that we can't continue to do business the way we're operating. It's not that we're going to go out of business, but if we want to continue operating like this, we would need to hire an additional 40 engineers, and there's no way they were going to do that. They were also trying to reduce costs, increase reliability, and bring some order to the approach that they were using for this integrated engine management world. So Temple was brought in from the outside. There was no position in the organization like his before he came in. So he was brought in basically to supervise all of these projects. And so you now had a change in the organizational hierarchy where these independent projects would no longer be allowed to operate totally independently. Temple was, in effect, the product line champion, even though at the time he wasn't called the product line champion or the product line manager. He was appointed to a new senior VP of engineering position. And his goal was, I'm going to standardize on our software development processes, I'm going to standardize on a tool set, I'm going to come up with an architecture and a set of components that will be reused across all engine management systems. And that way we will bring some discipline to this organization, and we will start to achieve our goals like shortening time to market and producing more reliable software and so on.